Lesson: Historical context of AI in cybersecurity. Artificial intelligence has been a transformative force across various domains, including cybersecurity. The historical context of AI in cybersecurity provides a profound understanding of how these two fields have evolved in tandem, shaping the current landscape of digital security. The interplay of AI and cybersecurity has its roots in the mid-20th century with the development of early computers and the advent of the Internet. As computing power increased and cyber threats became more sophisticated, the need for advanced defense mechanisms became evident, paving the way for AI applications in cybersecurity. During the 1950s and 1960s, the foundational concepts of AI were being developed. Pioneers like Alan Turing and John McCarthy laid the groundwork for AI by introducing concepts such as the Turing test and coining the term artificial intelligence. At the same time, the field of cybersecurity was beginning to take shape, largely driven by military and governmental needs to protect sensitive information. The development of encryption techniques and the establishment of secure communication channels were pivotal during this era. The 1970s and 1980s saw significant advancements in both AI and cybersecurity. Expert systems, an early form of AI, were designed to mimic the decision-making abilities of human experts. These systems were employed in various applications, including medical diagnosis and financial forecasting. Concurrently, the ARPANET, a precursor to the modern Internet, faced its first cyber threats, leading to the development of more robust security protocols. The realization that computer networks were vulnerable to attacks spurred the growth of cybersecurity as a critical field. The 1990s marked the beginning of the digital revolution, with the proliferation of personal computers and the Internet. This era witnessed a dramatic increase in cyber threats, including viruses, worms, and hacking incidents. Notably, the Morris worm in 1988 highlighted the potential for widespread damage caused by cyber attacks. In response, AI began to be integrated into cybersecurity solutions. Machine learning algorithms were developed to detect anomalies in network traffic and identify potential threats. For example, intrusion detection systems utilized AI to differentiate between normal and malicious activities, enhancing the ability to respond to cyber threats in real time. The early 2000s saw exponential growth in both the capabilities of AI and the sophistication of cyber threats. The rise of big data provided AI with vast amounts of information to analyze, improving the accuracy and effectiveness of machine learning models. Cybersecurity, too, evolved to combat increasingly complex threats, such as advanced persistent threats and sophisticated malware. AI played a crucial role in this evolution by enabling predictive analytics, which could anticipate potential attacks based on historical data. This proactive approach marked a significant shift from the traditional reactive methods of cybersecurity. In the 2010s, AI and cybersecurity became deeply intertwined. The advent of deep learning, a subset of machine learning, brought about significant improvements in pattern recognition and data analysis. Deep learning algorithms could process large datasets and identify intricate patterns that were previously undetectable. This capability was particularly beneficial for cybersecurity, where detecting subtle anomalies could mean the difference between preventing a breach and falling victim to one. For instance, AI-driven security systems could analyze user behavior and detect deviations that might indicate a compromised account. The integration of AI in cybersecurity has not been without challenges. One significant issue is the adversarial nature of AI, where attackers use AI to develop more sophisticated and adaptive malware. This has led to an ongoing arms race between cyber attackers and defenders, with both sides leveraging AI to gain an advantage. For example, AI-generated phishing emails have become increasingly difficult to distinguish from legitimate communications, necessitating more advanced AI-based detection systems. Moreover, the reliance on AI in cybersecurity raises concerns about the potential for false positives and false negatives. An overly sensitive system may flag benign activities as threats, leading to unnecessary disruptions, while an insufficiently sensitive system may fail to detect actual threats. Therefore, continuous refinement of AI models and algorithms is essential to maintain the balance between security and usability. In recent years, the concept of explainable AI has gained traction in the field of cybersecurity. XAI aims to make AI decisions more transparent and understandable to human operators. This is particularly important in cybersecurity, where understanding the rationale behind an AI-generated alert can aid in making informed decisions and improving overall security posture. For instance, if an AI system flags a potential threat, being able to understand the underlying reasons allows security professionals to verify the alert and take appropriate action. The historical context of AI in cybersecurity also highlights the importance of collaboration between academia, industry, and government. Academic research has been instrumental in advancing AI technologies and exploring their applications in cybersecurity. Industry partnerships have facilitated the development and deployment of AI-driven security solutions on a large scale. Meanwhile, government initiatives and regulations have provided a framework for ensuring the ethical use of AI in cybersecurity. For example, the National Institute of Standards and Technology has developed guidelines for implementing AI in a secure and reliable manner. Looking ahead, the future of AI in cybersecurity appears promising, with continued advancements expected to enhance the capabilities of both fields. The increasing adoption of the Internet of Things and the growing complexity of cyber threats will necessitate more sophisticated AI-driven security solutions. Additionally, the development of quantum computing poses both opportunities and challenges for AI in cybersecurity. Quantum computers have the potential to break traditional encryption methods, but they also offer new possibilities for creating unbreakable encryption techniques, necessitating further research and innovation in AI-based cybersecurity. In conclusion, the historical context of AI in cybersecurity illustrates a dynamic and evolving relationship that has significantly influenced the way digital security is approached. From the early days of computing to the present, AI has played a crucial role in enhancing cybersecurity measures, enabling more effective threat detection and providing predictive capabilities. As cyber threats continue to evolve, the integration of AI in cybersecurity will remain essential, driving the need for ongoing research, collaboration, and innovation to stay ahead of potential threats. This comprehensive understanding of the historical context not only provides valuable insights into the past, but also informs future strategies for leveraging AI to achieve enhanced cybersecurity.